Let's see the part 1 of motion of system, motion of system. So first question is about ring. So there is a ring from which 90-degree part is cut. So then it will be looking like this, right? So you have to find the moment of inertia of it. So I is moment of inertia of it having radius r. Understood? And perpendicular to the plane of the ring. So moment of remaining part of the ring about an axis through the center of the ring and perpendicular to the plane of the ring, that is k. And there is one ring whose plane of ring is given k and times k times m r square. So this is the plane ring having moment of inertia k m r square. Then the value of k you have to tell, right? So see here. So angle is given how much it is 90-degree, right? So as we know moment of inertia, it is given k m r square, right? And for the remaining part, so it will be m upon p equal to m upon 2 pi r. So this is the change in moment of r. Then it is change in mass will be p into dl. This is your p. And theta is given by arc upon radius. So change in length is dl is equal to r into d theta. So put the value here. So it is dm is equal to r is nothing but it is m upon 2 pi r, right? So this is m upon 2 pi r. So I have used this formula here and dl will become r into d theta. So this is your dl value, right? So put here. So it will be r into d theta, right? So let's see the next part. So di can be written as di change in moment of inertia is d into m into r square. So di will become now put the value of m. So it is m upon 2 pi r into d theta into r square. So it is di equal to this r will get cancelled. So remaining is m upon 2 pi d theta into r square, right? Now integrating both sides, so you will get, so integrating will be di equal to integration 0 to 3 pi by 2 m upon 2 pi r square d theta. So take the constant part outside. So it is m upon 2 pi r square. So integration of d theta limit 0 to 3 pi by 2. Right. So it is d theta. Answer will be theta. Now put the value theta, that is 3 by 2. Then you will get m r square by 2 pi. Instead of theta, you will put 3 pi by 2. So it is 3 pi by 2. Now cancel pi pi. Right. So remaining is m r square 3 upon 4. Right. So you have got I equal to m r square into k, right? So your final I is coming out to be m r square into 3 by 4. So compare this equation 1 and 2. You will get k as 3 by 4. So k is coming out to be 3 pi by 4. Now see the next sum. Next sum is two particles of mass m 5 kg and 10 kg respectively are attached to the two end of the rigid rod of length. So there is a rod, right? Two end of this rod is connected with, one is with 5 kg and another is of 10 kg. are attached to the two in rigid length is given, that is 1 meter. Right. The center of mass of the system from the 5 kg particle is nearly equal to. So from here, from this end, you have to find the center of mass of it. Center of mass. So let's see. So center of mass is given by this formula m1 x1 plus m2 x2 divided by m1 plus m2. Now put the value m1 is 5 and distance is 0. So we are taking this as a reference point. So it will be 0 plus 10 into 100. So 1 meter is equal to 100 centimeters. So I am taking here 100. So divided by sum of the mass. So it is 5 plus 10 coming out to be 1000 divided by 50. So this will get cancelled and this will be 20 center of mass. Right. This is not 50. This is 15. Right. So we have got the wrong answer. So erase this part. So addition is 15. Right. So this is 0 plus 1000 divided by 15. So it is coming out to be 67, right, centimeter center of mass. So this will be the answer for it. Now see the question number third. Third is talking about find the torque about the origin about a force. So force value is given, that is 3J Newton. Act on a particle whose position is given. So position means R value is given, that is 2K. And torque we know, this is represented as torque. Torque is nothing but it is force into perpendicular distance. So force is value is 3J and perpendicular value we know, that is 2K, right? So for finding the angle like IJK, this is I, this is J, this is K. When I cross J is there, then we get K. And when J cross K is there, when you move like this, you will product of this into this will get this. So J into K will get I. So it is I. So here J and K is applied, J and K. So will get I resultant. So 3 into 2 is 6 and the direction will be of I, right? It is asked in NEET 2020. And here sometime torque is given by this. So this is the formula. If you take for torque equal to perpendicular into force, then it is 2K into 3 of J. So we are moving in opposite direction, right? So when we move in this direction, opposite, then your answer will be minus of 6I, right? Direction is opposite. Now see the question number 4. Question number 4 is more about three identical squares, each of mass m, are placed at the corner of the right angle triangle with mutually perpendicular side of 2 meter. 2 meter, right? So this is your diagram given to you. This is I, this is J, this is the point M, here 2M. Right, this point is called capital M and this point is called capital M. So this distance is 2 meter, right? So taking the point of intersection of the two mutually perpendicular side of the origin, find the position of the center of the mass. So center of mass formula is given as M1 R1 plus M2 R2 plus M3 R3 divided by M1 plus M2 plus M3. So this is your mass 1, mass 2, mass 3. So I am taking this as a reference. So R1 we are getting as 0, right? R2 as 2I. So this is your R2 value, that is 2I. This is your R3 value, that is 2J. So put here. So you will get M into 0 plus M into 2I plus M into 2J divided by M plus M plus M, mass of each three particle is same. So it will be 2mi plus 2mj divided by 3m. So this is the resultant value we are getting about it. So take 2 as common and 2 by 3 and m also common. So it is I plus j. So this m and m will get cancelled. Your resultant will be looking like this. R of Cm is equal to 2 by 3 I plus j. This is the final answer for it. Now see the next sum. That is fifth one. Fifth one is total energy of the electron in orbit is given. So energy total of atom, that is minus 3.4 electron volt. If kinetic and potential energy of the value, you have to find it. So atomic to Bohr's atomic model, total energy is equal to kinetic energy equal to potential energy by 2. So kinetic energy value we have got, right? So your U will be minus of 2k U. Here I am taking mod, right? But initial potential energy, this is your U means potential energy. T means total energy. Potential energy. And K means kinetic energy. So U will be minus of 2 K. K value we know that is 3.4 electron volt. It is given, right? So this is your K value. So multiply it, you will get minus 6.8 electron volt. So remember the relation between them, then you will easily find it. Now let's see the next question. That is sixth one. So sixth one is talking about body of mass A. A mass is 4m moving with the speed u. So it is having u. Collides with another particle B. So it is colliding with another particle B having mass of 2m at rest. So its velocity is 0. So the collision is head-on and elastic in nature. After the collision, fraction of energy lost by the body A. So how much energy is losing this U? A energy of A lost. So let's see the sixth part. So the fraction of kinetic energy losing. So it is change in kinetic energy by kinetic energy. So it is 4m1 m2 divided by 1 m1 plus m2 whole square. So this is the energy we are losing it. So now put the value m1 m2. So it is 4 m1 value, that is 4m, m2 that is 2m divided by 4m plus 2m whole square. So it is coming out to be 4 into 4m into 2m divided by 4 plus 2 is 6. So it is 6m whole square. So it is 4 into 4 into 2 into m square divided by 36 m square. So this will be cancelled and this is cancelled by the 9. Right. So answer will be 8 upon 9. This is the relation change in fraction of kinetic energy to the total energy. Right. So right up to this point. Now look at the question number 7. A solid cylinder of mass 2 kg. This is your solid cylinder. So cylinder structure will be like this, right? This is your cylinder, right? Whose mass is given, that is 2 of kg and radius is 4 centimeter. Is rotating about an axis at a rate of. So at axis it is rotating at a speed of 3 rpm. That is dr by dt. Torque required to a stop after 2 pi revolution. So after 2 pi revolution, you have to stop it. So how much torque you will apply to stop it? So let's see the question number 7. Right. So applying work energy theorem. So see here how will you solve work energy theorem. It is given by W equal to 1 upon 2 omega F square minus omega I square. So as we know, initial angular velocity square is equal to how much? It is 3 pi, right? That is 3 into 2 pi by 60. So this is more about angular frequency. We are converting 2 pi into radian. So it is coming out to be how much? It is, this is cancelled with 2 0, this is cancelled by 10. So the answer is pi by 10, right? This is omega I, initial value. So let's see the initial angular velocity. So next one is theta. Theta given is 2 pi revolution, right? So for completion, it is equal to 2 pi into 2 pi. Total angle is 2 pi. So it is coming out to be 4 pi square radian theta. So when we have to convert one revolution is equal to 2 pi, you have to multiply, right? Now, put the value. So as we know, torque is nothing but it is, work is nothing but torque into theta minus of that. So here put minus of torque theta is equal to 1 upon 2, right, into. So this will be coming out to be 1 upon 2 m r square equal to in finally you have to stop, right? So final velocity will be 0. So it is 0 square minus of initial. So it is coming out to be how much? After putting you will get the torque, right? So let's see in the next slide. So torque you have to find. So it will be minus of 1 upon 2 into minus of 1 upon 2. M value we know that is 2. And R is 4 into 10 raised to of minus 2. That is minus 3, 2 square divided by 60 whole square. So this will be the whole square for that. Right, divided by 4 pi. So torque will be equal to, finally you will get 2 into 10 raised to of minus 6 Newton per meter. Newton meter. It is multiplied. Why Newton into meter? Torque is nothing but it is force into perpendicular distance. So force unit Newton and radius unit is meter. So torque is Newton into meter. So now see the next sum. Now let's see the 8th. So 8 is talking about two discs of same moment of inertia rotating about their regular axis passing through the center and perpendicular plane of the disc with angular velocity omega 1 and omega 2, right? So two discs are there. This is moving with angular velocity 1. This is angular velocity 2. Right, they are brought in contact to face, coinciding the axis of rotation. So one is keeping on the other two coinciding the axis, right? So its center will be same. So the expression for loss of energy you have to find it. As we know the conservation of angular momentum, so it is I omega 1 is plus I omega 2 is equal to 2I omega naught. So this will be the summation final, right? Initially they are separately moving. So you will get omega naught as omega will be the same for moment of inertia of the same disk. So you will get omega as omega 1 plus omega 2 upon 2, right? And we know the initial kinetic energy that is 1 upon 2 I. I means moment of inertia. I1 square plus I2 square. And final kinetic energy will be 1 upon 4 omega 1 plus omega 2 whole square. So though you can find now loss in change in kinetic energy, loss of change in kinetic energy. So it is I into omega 1 square upon 2 plus omega 2 square upon 2 minus omega 1 square upon 4 minus omega 2 square upon 4 minus 2 omega 1 omega 2 upon 4. So it is I into omega 1 square upon 4 plus omega 2 square upon 4 minus 2 omega 1 into omega 2 upon 4. So LCM is 4, so take it out. So your answer will be omega 1 minus omega 2 whole square. So omega 1 minus omega 2 whole square, why it is so? It is a square plus b square minus 2ab, right? We have taken the 4 outside. So this will be the final change in kinetic energy loss value.